Hey everyone, so today we're going to be solving systems of equations by multiplication, level 1, so we're only really going to be focusing on one equation at a time today. So let's get started. So the first thing we want to talk about today is identifying strategies. So for example, if you have two equations and you have a pair of additive inverses, you're always going to evaluate, do I have that? What do I do? If the answer is yes, you're going to add those equations together and solve. Also ask yourself, do I have identical terms? So do I have two terms that are exactly the same, same sign, same variable, same coefficient? If the answer is yes, you're going to use the subtraction technique, or multiplying one of the equations by -1 to create those inverses and solve. And then the last method that we looked at, do I have an equation in the form of x equals or y equals? If the answer to that is yes, you're going to use that substitution method and solve. So these are the first three questions I always want you to ask yourself when we're taking a look at systems of equations. So what we're going to focus on is if the answer is no to all of these questions. So before we get started on how to do it, we have to review what a least common multiple is. And hopefully that sounds familiar from either elementary school, middle school, from the past. So the least common multiple is the smallest positive number that is a multiple of two or more numbers. So we are going to be finding the least common multiple of two numbers. We're going to list all of the multiples, and we're going to see what the smallest one they have in common is. Please do not get this confused with greatest common factor. That's probably like the number one misconception with least common multiple. Think multiple, you're multiplying. So we're listing all of the multiples as if we were multiplying 8 times 1, 8 times 2, 8 times 3. So identify the least common multiple of the following sets of numbers. So we're going to focus on 8 and 16 right now. So like I said, we're going to list the multiples of 8. So we have 8, 16, 24, that's a 4. Just make it look a little neater. Then we have 32, 40, 48. So I'm just multiplying these in my head, right? 8 times 1, 8 times 2, 8 times 3, and so on. This is a list that's going to keep going on and on forever because you can always keep multiplying. So now I'm going to do the same thing with 16. So we have 16, 32, 48, 64, 80, 96, and so on. So we could have stopped a bit ago because hopefully you've noticed that there is a least common multiple. The smallest number that both of these lists have in common is 16. So there's a 16 here and there's a 16 here. There's also a 32, there's a 48, but this one is the smallest one. So that's why we want to focus on that. So the LCM of these two numbers is 16. Okay, we're going to do the same thing with 10 and 6. So I'm going to list all the multiples of 10. We have 10, 20, 30, there's underline that, 40, 50, 60, so on. And now let's do the same thing for 6. 6, 12, 18, it's a comma, 24, 30, 36, 42, and so on. Hopefully you notice they have a number in common. The smallest one they have in common is 30. Okay, so the least common multiple here is 30. So this is really important to remember. You're going to have to use some math sense, some mental math in this lesson and in the next few lessons, and just referring to these timetables and how to find a least common multiple. Okay, so let's take a look. So solving a systems of equations using multiplication, level 1. So this is the system that we want to solve. Okay, and these are going to be some questions that we want to ask ourselves, as well as some steps. So the first one is, do any of the situations from slide 1 apply? So remember, it was, do we have a set of inverses? So that means same term, but opposite signs. So they have to have the same number, same variable, different signs. These aren't inverses, and these aren't inverses. Remember, if you add inverses together, you should get 0. And none of these, if we add them together, are going to give us 0. So we don't have inverses. Do we have identical terms? No, we don't have two terms that are exactly the same. And we don't have an equation in the form of y equals or x equals where we would be able to substitute. So the goal for today is to create a set of inverses. And to create a set of inverses, we are going to be multiplying by some number. And the hardest part of this is finding that number that we multiply by. So you're going to ask yourself, what number do I need to multiply by to create a set of inverses? So that's the next question. What number do I have to multiply by to create a set of additive inverses? So what we're going to do is we're going to look at the coefficients and see what would make inverses if you multiplied by it. Okay, so we can use the LCM of each pair of variables to help you. So just like we did in the slide before, 16 and 8. The LCM here was 16. So I'm going to list that right here. And the LCM of y for this 10 and this 6, and notice I'm not paying attention to the signs for right now. 10 and 6, the LCM was 30. So what we want is we want either the pair of x's to become both 16s, the coefficients in front, or we want the pairs of y, both of those coefficients, to become 30. So now notice here, this equation already has a coefficient of 16 here. So we would not have to change this. The only thing we would have to change is this negative 8, right? We want this negative 8x to become a negative 16x. So we wouldn't have to change this, we would have to change this. Now, if we were focusing on the 30, neither of these have a coefficient of 30. So I would have to multiply this by something to get 30 and this by something to get 30. So we want to do as little work as we can because that means little work. Less work means less mistakes possibly made. So also 16 is a smaller number. So this is the LCM that I'm going to focus on. It's going to give me the least amount of work to do. So that's what I'm going to focus on. So like I said, 16, this is already 16x. We don't need to change that. So I'm going to put a little check mark there because I don't need to do anything to that first equation. Now, this negative 8x is not a negative 16. So you have to say, okay, what do I have to multiply negative 8 by to make that a negative 16? So what you can do is take 16 and divide it by negative 8 and see what you get. We'll divide it by 8 and see what you get. And in this case, it's 2. So what I'm going to do is I'm going to multiply this entire equation by the number 2. And you're going to see what happens here and why I'm doing that. Okay, so that was just the third step. Multiply all terms in one equation to create that set of inverses. So we're going to multiply every single term here, and that includes over here also. So I'm going to just rewrite it. 2 times negative 8x gives us negative 16x. 2 times negative 6 gives us negative 12y. And then equals 2 times 6 is 12. Okay, so we multiplied every single term by 2. Remember, I didn't do anything to that first equation, so I'm going to just rewrite it right on top of it. I didn't change anything, so I just rewrote it. And notice here, we have a 16x, and then we have a negative 16x. We created that set of inverses. And when we have inverses, we're able to just add these together and solve it the way we normally would. So we identify those inverses. 16 and negative 16 cancel out when you add that, and then add everything else. Negative 10y and negative 12y gives us negative 22y, and 10 plus 12 gives us 22. All right, now we're going to solve it the way we normally would. Divide by negative 22 on both sides. That cancels, and we get y equals negative 1. Okay? So we multiplied by that 2. We didn't do anything else with the 2. Once we're done with that, we don't have to come back to that. You just have to multiply to create those inverses. Now remember, we're solving a system of equations. So we have y. Now we have to solve for x. So I'm going to just rewrite one of the equations. Remember, same as we were focusing on in the previous lessons, do not substitute into the new equation. Choose one of the original equations, because just in case you made a mistake, then it's just going to lead you to an even more incorrect answer. So we're going to use one of the first original equations. I'm going to use the first one. I didn't touch it, so I'm going to just use that, but that's up to you. You can choose either one. It's going to give you the same answer as long as everything else is right. And now instead of writing y, we're going to substitute -1 for y. So I'm going to just bring everything else down. And instead of writing y, I'm going to write -1 in parentheses. Do not forget those parentheses. It's very important. And we're going to solve from there. -10 times -1 is a positive 10. And then bring everything else down. Oops, that should be 16, not a 6. 16x plus 10 equals 10. If you want, you could draw your train tracks if that's going to help you stay organized. Subtract your 10 on both sides. So we get 0. Bring down your 16x. Just move that over. Divide by 16 on both sides. And you get x equals 0. Remember, don't forget to write your answer as an ordered pair. X comma y, 0 comma -1. So that is our answer here. So because these are kind of long examples, we're only going to look at this one today, so I'm going to just re-summarize what we did. I noticed that we did not have a pair of inverses here, and we didn't have identical terms, and then we didn't have an equation x equals or y equals. So I knew I wasn't going to be able to do one of the first 3 methods that we learned. So we had to create our inverses. I used the LCM and I asked myself, okay, what could I multiply this by for these to become additive inverses? It was already negative, so I didn't have to multiply negative. Sometimes you will. But just by me multiplying everything by 2, I was able to create those pair of inverses. Because 16x and -16, when you add them, they're going to cancel out. Then from there, I just solved as we normally did. You add both equations together, solve for y, then substitute your y into one of the original equations to solve for x. Write your answer as an ordered pair. So this is probably the trickiest part, so really take your time. And remember, if you add and something doesn't cancel out, then you know you did something wrong. Okay, good luck.